Hello students, so today we'll continue from the same unit data structure and from the same chapter arrays. So in today's content, we'll be discussing about one-dimensional array memory locations, two-dimensional array, two-dimensional array in memory locations, row major order, and column major order. So we shall see all of this one by one. Now, one-dimensional array in memory locations. So since you're already familiar with the array, so normal array is a one-dimensional array. So array stores data in contiguous memory locations in a linear or sequential structure format, right? So one after the other. So array elements, they are stored with data values in sequence one after the other. So now, in order to find how array stores the data in memory locations, we can perform calculations as follows by using this formula. Okay, the address of the ith element equals to base address plus element size, okay, within the bracket I minus L. So if we know the base address and the element size, okay, and the L, that is the lower limit of the array, okay, then we can find the address of the ith element. So this ith element, okay, this is the element number in the array. We are going to search for that particular memory address, and here the address of the first element is called the base address of the array, that is represented by, denoted by P. So P is the address of the first element. Okay, so it is the address of the first element, and here L is the lower limit of the array. So the that would be the first element. Okay, and then here I is the element number in the array for which you are searching the address of the memory location, and here element size W is the memory word allotted based on the data type. So example is, okay, integer is occupies one memory word, that is like 2 bytes, and real type, it occupies two memory words, so that is 4 bytes. So which means that, okay, one memory word occupies 2 bytes of memory, and two memory word occupies 2 bytes or 4 bytes of memory. Okay, so here W represents the memory word allotted, okay, to the variable according to the data type. So now let's see an example on that, on this one-dimensional array. So here in this example, find where the indicated components of an array A of specified type are stored if the base address of A is 100. So here in this we have an array called as A, okay, and there is a specific type for that. So that is the type of this array is real type, okay, and then we have to find the array element memory location, that is A1 and A4. So here this array, the the length of this array is starts from array 1 to array 10. So you have 10 array elements starting from array 1, array 2, array 3, array 4 till array 10. Okay, so now they are all are of real type. So now from here the base address, or the base address of the first array element here is 100. Now we have to find the address of A1 and the address of A4. So A1 represents the first array element and A4 represents the fourth array element. So we have to find the memory location of both of these array element. So now the solution is, okay, B is 100 because B is already given. Base address of A is 100. Okay, so which means that the array element, okay, A1, okay, is it's already denoted here. Array element A1, okay, base address is 100. So now we have to solve it using the formula. Now here W is 2. W is 2, which is the memory word occupied by real type, right? So real data type occupies two memory words, which is 4 bytes. So now according to the formula, ith element equals to b plus w within bracket I minus l. So here l is the lower limit, which is 1, and the upper limit here is 10. Okay, so since we have area element starting from area 1 till area 10 here, so the most lower limit here is 1 and the upper limit here is 10. So now when we execute that formula, uh, A1, which we're going to search, the memory location of A1 equals to 100 plus, okay, 100 plus 2, which is the memory word, okay, my within the bracket 1, which is the I, right? So which is the ith element, and the element number is 1. So minus the lower limit here is 1. So when you execute that formula, you get the value 100. So which means that A1, the array A, first element 1, memory location is 100. So you can see that it matches with the base address of A is 100. Okay. Now next is again, now we found the memory location of A1. Now we have to find the memory location of the array element A4. So here A4 equals to 100 plus 2. I is here 4. I is 4, which is the element number we are searching for. So that's why it's written here 4. And 4 minus 1. 1 is the lower limit here, right? Because the first array element here is 1. So once you execute this, you get the value 106. So you see that A4 memory location is 106, which is in a sequential format because here A1 is 100, right? A1 is 100, and each element occupies two memory words. So if A1 is 100, A2, let's say, is 102, uh, A3, right, is 104, A4 is 106. So you can see that it matches because the memory address location is also in a sequential order based on the type. So here the type is real type. All right. Next is two-dimensional arrays. So an array of array is a multi-dimensional array. Okay. So when you have two arrays combined, okay, you can make it into a multi-dimensional array. So a two-dimensional array is also called as matrix array, where two one-dimensional arrays are represented by rows and column format. Okay. So here is an example to make you understand better. To calculate marks of three students, now you have to calculate marks of three students uh, having four different marks. So that means uh, marks in four different subjects of three students. Okay. So this matrix contains three rows and four columns, which can be represented as, okay. So when you combine two arrays, two one-dimensional arrays to form a multi-dimensional array or a matrix array, okay, that is 2D array, uh, you have two index. Okay, so here in this example you can see that in score, score is the name of the array, okay, and you can see that the subscript 3 4, right, within the square brackets. So 3 represents the row and 4 represents the column format. So that is combination of two arrays, score 3 and score 4, like that. So here uh, the array score 3 4 is initialized with the values 50 40 30 75 in the first row, okay, 65 54 76 in the second row, okay, and 45 67 like that in the third row. So now we have to enter this data in the matrix. So if you can see the table structure, okay, so in the first column, okay, that is in the first index, that is marks 0, which is in a rows and column format, it will be marks 0 0, okay. So and in the second column it is marks 1. So marks 1, which is like marks 0 1, and then next is marks 2, that is marks 0 2, okay, marks 3. So you can see that each student has its own row. Student 1 rows, okay, contains the marks of 4 different subjects. Student 2 rows contains marks of 4 different subjects, and student 3 rows contains marks of 4 different subjects, okay. So column wise it is like subject wise, and row wise it contains the date marks of the 3 students. So now what we have to do is, if suppose the marks of all these 3 students are increased by 10 marks, okay, then each subscript of the array will be added by 10. Since in each subscript all the marks are entered, okay, all the marks are entered, so if it is increased by 10, all the array subscripts will be added by 10. Like here, int score 3 4 equals to, right, int score uh, in score 3 4 equals to score, okay, in the row is 3 and column is 4 plus 10. So this will add up in all of the rows and columns, okay. So the new score format will be, you can see that it is rows are all the rows row wise and column wise, okay, the marks has increased by 10 10. So now this addition of the value of the value 10, okay, on the two-dimensional array matrix, it can be done either in row by row format or column by column order, okay. So you can first uh, fill up the add the value 10, okay, row wise, okay, according to the first row, second row, third row, or you can add it according to the first column, second column, third column, fourth column, like that. So that format, okay, where the order of visit row by row, it is called as row major order, okay, and if it is done column by column, it is known as column major order, okay. So we shall see what is this row major order and this column major order. So under two-dimensional arrays in memory locations, okay, the elements of the two-dimensional arrays, it can be stored in the memory in two ways. So the first one is row major order. Now in this method, the elements of the first row will be stored first, okay, and then the elements of the second row, and then the third row, and so on and so on, okay. So suppose to calculate the I and j address of any ij element in the array, okay, the following formula will be used. So of any ij element, okay, that means suppose like the first element, that is 0 0, and if it is the second element row wise, it will be 0 1, okay. So suppose like if you are searching for say like 60, it will that will be the first element in row wise, that will be row 0 column 0, okay. And if it is suppose like 50, that will be row 0, row is 0 and column is 1, okay. And if suppose you are searching for the value 75. That will be okay, since it is in the second row, so it will be row 1, right? So 1 0, right? And if it is 64, it will be 1 1, like that. Okay, so first row and then second will be column in this row major order format. So the formula that will be used is address of ij element equals to base address plus element size, okay, within the bracket number of columns, uh, I minus lower limit of row plus j minus lower limit of column. So when you execute this formula, you will get the uh, address of the memory location of the ij element in the array. Okay. So here is an example, an array T 1510, which means 15 rows. This array T, the name of the array is T. This array T contains 15 rows and 10 columns. 15 rows horizontally and then 10 columns vertically. So this element requires 2 bytes of storage. Okay. So now we have to find the location of T7 8 using row major order. So what is the memory address of this array T under 7 rows and 8 columns format? Okay, so now we have to find the address of that particular order. So here's the solution. Okay, so B is let's say B is assigned, the base address is assigned the value 200 or 2000. Okay, the base address memory location is supposed like 200. Okay, so here W is assigned, the memory word is assigned the value 2, which means that it is real time. Okay, so here L1 and L2, which means the lower limit of L1 is row and L2 is column, the lower limit of column is 0, so which means that they are starting from the first element 0 comma 0. Okay, here n is the uh, length, okay, of the row format, that is 10. Okay, and here m stands for uh, column. Okay, so now based on that, when we execute the formula, you get the value 2156. Okay, so this is the memory location of the array where the row is 7 and the column position is 8. All right, so using this row major order, we can find the ij element, okay, of any element in the array. Similarly, for column major order, it's quite the opposite of the row major order. Here in this method, the elements of the first column are stored first and then the elements of the second column. Okay, so to calculate the ij address of any ij element in the array, okay, we use the following formula. So you can see that the previous formula and this formula are almost the same, except that uh, they are interchanged. Like suppose like here, base address plus element size. Okay, instead of number of columns, now it becomes number of rows. Instead of I, it is j, and lower limit of column instead of lower limit of row. Okay, so similarly here, in the last plus, I minus lower limit of row. In row major order, it was j minus lower limit of column. Okay, so the same example. Okay, here the array is T and then row is 15 and column is 10. Okay, the size of the element. So it is so it requires 2 bytes of storage. So now again we have to find the location of the array element. Okay, T78 using this column major order. So the formula is same as is mentioned in the format. Okay, so when you execute that, the same values are given. Okay, b is given the value 2000. Okay, w is 2, L1 and L2 is 0, N is 10, and M is 15. So when you input those values and execute the formula, you get the memory location as 2254. Alright, so using this column major order and row major order, okay, we can accurately find the memory location of that particular array element. Okay, so so we have come to the conclusion of this particular chapter. Okay, and in the next class I'll be discussing from the solve exercises some of the examples. Okay, so just go through this topic, okay, and then compare this with your textbook examples. Okay, so yes.